Okay, let's just do a quick little mic check. Seems like the mic check is okay. We'll cut that echo off. All right, so welcome back to what I anticipate will be the final installment of my Atari 5200 programming tutorial series. It's been a fun ride, but I think it's about time to wrap this up because I think I've covered pretty much everything I want to cover at this point. But I want to put a couple of additional touches on this Tetris game before I call it done. So, just to wrap up where we're at. So, we made this somewhat passable Tetris game. It's mostly functional at this point. We got fast drop, we got rotation on the pieces, collision detection's all there. Now, one thing that is not here is we don't yet have code to detect and remove lines once they're completed. So that's the main goal that I want to achieve today, and probably the only thing I want to achieve today, apart from one very small bug fix. So there is a glitch here, and it involves the very top of the screen. See if I can get a piece that shows it. So sometimes the rotation checks go off the top of the screen and cause bad things to happen. So we're going to put in a quick fix for that, just for the sake of completeness. I need to get the right piece for that to happen, though. I think it has to be one of the T pieces. Yeah, these pieces don't show it. Come on. Give me a... I might have to force it in the code to make sure that it's fixed. Okay, yeah, it's the T piece. The T piece is really the only culprit here. Yeah, there we go. See, when I rotated that, it screwed up. And the reason it screwed up was because it was validating the rotation by looking off the top of the board. And it was going into memory it shouldn't be going into. So the first thing I would like to do today is to address that issue, and I have a very quick way I can do that. But the first thing we're going to do is we need to make sure we can test it. So we need to force the T piece to show up all the time. Looks like that's code number 4. So I'm going to go here to where we load the random value. And instead of loading a random value, let's load number 4. So now we're just going to get nothing but T pieces. So what we're going to do is we're going to insert a sort of logical top row above the top row of the pit. That's just solid block. So when it checks to rotate, it says, oh, no, you can't do that. Or, you know what? Actually, now that I think about it, that's not that great of a solution. I think most Tetris games kind of allow pieces to go off the top of the pit, and I didn't really do that here. And it would require a significant amount of re-architecting to allow that. So I think what I might do... You know what? I think I'm just going to let it slide. Who cares? It is a bug in the code. It is a known bug. So hey, if you're interested, go grab the code from the Atari Age forums and fix it yourself. I'll leave it as an exercise to the viewer to fix that bug. What I want to do now is to look into line detection. So there are really 3 different tasks that need to be achieved here. The first is to detect that a line has been completed. The second task is to clear that line. And the third task is to shift the board down after the line has been cleared. Now, the first two things are simple. The third one is a bit harder, and I think we're just going to brute force it. There's probably a much easier way to do it, but I don't care. All right, so let's look at step 1. Well, the first thing we need to do is we need to find the place in the code where the piece becomes grounded, because that's when the check for the completed lines is performed. So now I wrote this routine called generate new piece. And I bet you I call that when a piece gets grounded. I haven't looked at this code in about 2 weeks, so... can't type today. Okay, here we go. Oh wait, no, that's the beginning. That's to generate the first piece. Alright, here we go. Ah, and even put a to-do for line checks. Here's where it goes. Okay. So let's think about this logically now. So when you drop a Tetris piece and it hits the ground, which lines do you need to check? Well, the answer is you only need to check the lines that correspond to the piece you just dropped. So in this case, we only need to check 3 lines if it's rotated like this. If it's rotated like this, we only need to check 2 lines. So what we need to do is we need to look at the Y value of each block of the piece that just fell. And those are the lines we need to check. Now, there will be duplicates, but I don't think it's worth trying to avoid the duplicates, because if we check one and we say, yeah, that's a line, we're then going to clear it, and checking the next one will say, no, that's not a line. It'll fail very quickly, because it'll look at the very first block and say, whoop, not a line. So this is one of those cases where, I mean, in general, especially in assembly, you want to do as little work as possible. But sometimes it takes more work to figure out what work you need to do than it does to just do the work. And this is one of those cases. So we're just going to do it. We're just going to check it and go. So let's do this here. Now, the way the piece is stored in RAM is as a sequence of 4 XY pairs, because it's made up of 4 blocks, and we put them all together. So we have piece X, and we have 4 bytes reserved for that, and piece Y, we have 4 bytes reserved for that. So the 4 blocks that comprise each piece, each have an entry in piece X and an entry in piece Y. So we need to go through these entries, one at a time, and check to see if there's a row clear there. So here's what we'll do. We'll set up a loop. So we'll start with an offset 3. That'll be the last block, and we decrement and go down. So we'll call this the line check loop. So let's look around the code here and see what we have to work with, because I know I've written a lot of, we put that to-do back, because that way I can search for it and go right back to it. I know I wrote something that takes piece coordinates and maps them to the memory cell where the piece is located, but I can't remember what I called it. Generate new piece, validate piece, update current piece, cell to address. Here we go. All right, so I bet I put... All right, let's see how... I didn't write comments on how to actually use these routines, which I probably should have done. I usually do that, but for this I didn't do it. I need to see how... Okay, well there it is. I use it right here. How does this work? All right, so in X we put the current piece X, and the accumulator put the current piece Y. All right, seems easy enough. So we'll go back to the to-do. All right, so what we're going to do here, then, is first thing we need to do is to loop through every piece and see if this is one of the pieces. But, you know what? I need to look at something real quick. I'm not going to be able to keep that index value in X because it's going to get clobbered. So, yeah, I'm going to need to put it somewhere else. All right, cell to address. All right, so cell to address uses F0, FE, and FF. Okay. Cell to address. Okay, yeah. Oh, wait, that's validate piece. Cell to address uses all the registers. FE and FF. Okay, gotcha. All right, so we're going to need to store things a little bit different. So FE and FF are used by cell to address. So what we're going to do is we're going to take this value that we're using to index, and we're going to put it in F0 so we have somewhere handy to put it. So the first thing we do then is we load F0. This is redundant for the first loop, but it's what I got to do. And we're going to load test. Oh, can I load directly into Y? I don't think I can. Test piece Y, X. I don't know if I can do that. Oh, I can do that. Nice. Sometimes I forget which addressing modes I can actually use. Oh, not test piece. No, no. Test piece is where I put stuff for validation. We want current piece X. Yeah, I was looking at the wrong thing. Current piece X. Current piece Y. No, we did Y first. Okay. There. Okay. All right, so now we have the two pieces. So now we jump to cell to address. And this will take those coordinates, find the cell in memory that corresponds to that spot on the board, and put it in address FEFF. So now we just need to look at what's in that location all the way across the board. Now, there are 20... It's 10 wide. It's 10 wide. So here's what we're going to do then. So, no, this is wrong. We don't want that. What we want is the left edge. So what we want is the Y coordinate of the block with an X coordinate of 0. We want the left edge. So I actually did this wrong. So we're going to load a 0. Except, no, 1, because I've got like the edge thing. Okay. Okay. This is what happens when you don't look at the code for a while. I need to go look how it is, because we have like dummy blocks off the left edge, so I need to figure out what the actual coordinates are. And the best way to do that is by looking at the piece mappings. Okay, so the L pieces start at location 5. So let's look at where an L piece is. Oh, wait, there's a square piece, and that's like dead center. So what are the coordinates on the square piece? All right, x5 and 6. So if it's 10 wide, then that means that we actually want 1. So, yeah, so 1, the coordinate 1 is the left side of the pit. And then y is the y coordinate of the first block in the piece. So that's where we're going to start looking across to see if a line has been cleared. So there are 10 cells across. So we need to look at all 10 cells. And if they're all empty, and if they're empty, if they're all full, and they're full if they don't equal 0, then a line has been cleared. So what we'll do then is we will load 9 into X. So this is the rightmost cell. Then we will load the address there. Oh, you know, I think this has to go into Y. Index by Y. Now, if this equals 0, it's empty, and this is not a row. So we can move on to the next piece. So BEQ, not a line. We'll call it a line, not a line. So if it's not a line, we're going to decrement our block index in F0. And if that does not equal 0, no, if that is 0 or higher, it means we're not done with the loop yet. So we go back to line, check, loop, and check the next block. Now, here, it isn't necessarily a line. We still need to keep checking, because we just checked one block, said, okay, that's a line. So we actually need to put another loop here. We'll call it cell check loop. So here we're going to decrement Y. And as long as it's 0 or higher, we go back to cell check loop. Now, if Y actually makes it down to -1, that means that this is a clear row. So if we get to this point here, this is a clear row or line. We'll call it a line. I can't get my term straight. Line is clear. So what we're going to do is our old friend here, increment the background color. Actually, you know what? Better idea. Let's do our old friend jump star. So if you're not familiar with jump star, it creates an infinite loop. It just keeps jumping back to itself. So if this is correct, as soon as we make a row, a line, the game should freeze up. That way we know we detected it. So let's see what happens. So I want to make a row as quickly as possible here. Can I sneak this under there? Yeah. Oh, that was close. Okay. All right, here we go. So it should lock up now. Oh, it did not lock up. All right, so we did something wrong here. So let's go back and look at the code. All right. Let's go over this again. All right, so we put the number 3 into location F0. This is our block index. So we need to check all 4 blocks in the piece that just dropped. Oh. I see the problem. This is after generate new piece. So the piece has already been cleared out. So I think the logic might be correct. It's just that we already wiped out the piece data. So we need to take this and put it here. All right, we'll try that again. I didn't even notice that. Okay. So make a, ooh, this is a good start. And here we go. Okay, it still didn't work, so something else is wrong. But that was definitely wrong. That was definitely a problem. So let's find out what the actual problem is here. All right. So let's look at this one more time. So what do? We take the number 3, we stick it into F0. This is our, wait a minute. Is F0, does that get clobbered? No, it doesn't. Okay. You gotta be careful with your memory scratch locations because it's very easy to like call another function or subroutine that overwrite the scratch location you're using in another area. Okay, so we take the number 3, put it in the location F0. That's our index, our block index. So we gotta check all 4 blocks. Now we take that index, which I typoed. I put F9. That might be the problem. My eyes are not great. Sometimes I don't see this stuff. All right. Well, now we'll try it. I love it when the algorithm is right. I just make stupid mistakes like that. Okay, here we go. Here we go. Okay, still not working. All right, so what do we got? All right, so we load the block index into X. We load the current piece's Y coordinate into Y. Then we put the number 1 into the accumulator, and we jump to cell to address. So let's go down to cell to address. Okay, so. Oh, I'm using it wrong. It's X in X, Y in the accumulator. I used that wrong. Okay. That's my problem. Using my own functions wrong. Okay, so we're going to put then the block offset into Y. Then this goes into the accumulator. That goes into X. Okay. So we were just checking the wrong. We're like checking some bizarre random memory location there. I'm checking the 4 lines that are in the block, like the 4 lines that correspond to the block that just got dropped. So there could be duplicates. And I usually don't label my scratch addresses. Sometimes I do, like for very complicated functions. And I can't get the, okay, I just want to make a line, come on. I gotta wait for, we'll get one eventually. Here we go. Okay, something's still wrong here. This is what happens when I don't touch code for 2 weeks. All right. So let's look again here. So cell to address puts the address of those coordinates into FEFF. Then we, why did I do that? Oh, I'm looking in the wrong place. Okay. So let's see here. Line check loop. All right. I'm going to have to step through this with a debugger and find out what's happening. All right. So cell to address 9. So there are 10 cells in a row. So we start from 9 and work down. Offset 9. So we load the cell value in offset 9 from the address. And if that equals 0, it's an empty space, which means we haven't cleared a line. If we haven't cleared a line, we decrement the block index and jump back to the line check loop and check the next one. That's fine. If it is not 0 in that cell, that means there's a block there. So we decrement Y, which moves us to the next block down. And as long as that's not negative yet, oh, that's right, because we start at 1. I'm off. I'm off by, I forgot. We have that like fake row on the left side to aid in rotation checks. So I'm actually checking the wrong values. We need to start from address 10, and we need to branch on not equal to 0. Because the range we're looking at is 1 to 10, not 0 to 9. Silly mistake. All right, let's see what we can do here. If this doesn't work, I'm going to step through it with a debugger and figure out what's happening. Okay, it's still not working. Wait, no, I didn't finish a line. Oops. That's dumb. Here we go. And there we go. Okay. All right, so we just detected that line being complete. So the algorithm was mostly right. I just screwed up a couple of details. All right, so here at the jump star, this is where we need to now clear the line. And the way we're going to clear the line is really quite simple. So we have the address of the line in FEFF. So we just need to write zeros all the way across the line. So we're going to go back to offset of 10. We'll call this the... Yeah, actually, I can just... We can load 0. Wait a minute. Okay. Here's one of those cool little assembly space-saving tricks. So the branch right before this line is branch on not equal to 0 to cell check loop. So if we're at this line, that means that y is 0. So instead of loading the accumulator with 0, which is a 2-byte instruction, I can just transfer y to a because I know it's 0. So it's only a 1 byte. Just notice that. And then we're going to load y with 10. That's our offsets. We're going to clear the line now. We'll call this the line clear loop. And then we're going to write that 0 to that address, decrement y. Okay, now, once y equals 0, we're done clearing the loop. So then we're going to branch to... well, actually, we want to fall through to not a line at that point and start the next iteration, because there could be more than one line checked. So if we're not equal to 0, we go back to line clear loop and continue clearing the line. All right, I believe that will clear the line. Now, we haven't dropped the board yet. That's going to come later. But I'm pretty sure that will clear the line. So let's find out. Random number generator hates me. There we go. Oh, 2 lines. Ugh. Okay. It didn't quite work. It cleared something. And it also didn't catch the other line. So, still got some work to do. We're getting closer. Getting closer. Oh, you know what? No, 9 was right. Wait a minute. All right, I'm a little confused now. I think when we picked up that line before, I think it was right for the wrong reasons, if that makes sense. Let me adjust this here. I'm a little confused as to why this worked. Of course, this has to actually be a load 8 number 0 now. Because the address of the cell is actually cell 1. It's the... Yeah, I made a mistake here. Maybe I should change the random number generator to just give me one piece over and over again so I can easily make a row. Oh, there we go. Okay, now it's working. Excellent. So that row has been cleared. And I would like to set up a situation where I clear 2 rows at once. This is kind of an interesting way to play Tetris. Just have the board never drop. Yeah, I want to clear 2 rows at once, so let's try to make that happen. All right, so as soon as I get along, there we go. Ooh, it didn't clear both rows. Okay, closer though. So I suspect that it's not, that the code isn't continuing with the checks after we clear the loop. So let's see here. All right, so once the line is done being cleared, it's going to fall down here. It's going to decrement F0, which is the block index. As long as it's positive, it's going to go back up to line check loop, which should do the next row. So I don't really see why that would be failing. Oh, because I indexed it wrong. That just happened to be working for the very first time through the loop. All right. Oh, programming's so much fun. All right, so now we got to set up a 2-line clear, and I think it'll work now. There we go. Here we go. And there we go. Okay. All right, so we got line clearing working. And now we need to do the hard part, which is dropping the board after the line, after the rows are cleared. And this is tricky. I've been thinking about how to do this all week, and I'm still not exactly sure how I want to do it. Now, I suspect that there's probably a very I suspect there's probably a smart way to do this and a brute force way to do it. And I think I'm probably going to go with the brute force method. But let's see. So in effect, what we need to do from a logical standpoint is for every row that's cleared, we need to drop every row above it down 1. Now that's kind of the brute force method. However, that's going to cause some problems with our line detection because the coordinates of the piece will change when we drop the blocks. So I think the way to do this then might be to record the y coordinate of every row that gets cleared. And then once we're done checking all those rows, we can go back and do the adjustment. I think. That feels like the right way to do it to me. It's going to be ugly no matter what we do, and it's probably going to be slow. I've been trying to think of a clever way to do this, and it's been so long since I've done Tetris, I've forgotten how to do it. So here's what we'll do. All right. So I usually like to code things like this from the bottom up, in that I like to start with the most fundamental, like, last thing that you do and then work back upward. So instead of thinking right away about how are we going to store the rows that are going to be dropped and do all this, let's start from actually doing the row dropping and then work our way back to that. So I think the first thing we need to be able to do is we need to have a routine that will take a row and drop it. Because right now we don't have that. So let's go ahead and I'm going to leave this to-do here just so I can search and go right back to it. So I'm going to write a new subroutine that deals with this problem. That drops. Okay, here's what this routine will do. It'll take a y coordinate and it'll drop everything in the board. Okay, so here's where things get a bit tricky. Because if we store y coordinates and then process them one at a time, processing one will change the y coordinates of the other rows because the rows are going to move. So I think what we need to do then, maybe, You know, there is an incredible brute force method that could be used to do this. And that is, we just start from the bottom. If the row on the bottom is clear, drop the row above it down one. If it's still clear, drop it again. The question is, how do you stop? I think that's the tricky part. I think there might be something to that, though. Or maybe we start from the bottom. If a row is clear, I'm going to sketch out an algorithm here. Start from bottom. Yeah. I'm thinking maybe what might work. Well, okay. I think the way to do this, it depends on if I'm going to record the rows or not. Because what I could do, an alternative to this, like another way you could do it, is if I record the rows that are cleared in a short list, I take each row, I drop everything to that row, and then I go through the rest of the list, and for every row that's higher than that one, I decrement it. Or increment it. It would be increment or decrement. I can't remember which way I numbered the board. But I would adjust the list after every row I do. Maybe. Actually, I think the first thing you do is figure out which way the board coordinates go, because I can't remember. Okay, 0 is at the top. All right, so the bottom row is 20, or 19, actually. Okay, I think I'm just going to brute force this for the sake of doing it. It's probably going to be slow as hell, but it'll work. So here's what we're going to do. We're going to start from the bottom. Is the line clear? If the answer is yes, then we have to ask, is there anything above the line? Actually, no, the first question we need to ask is this the top line? If the answer to that is yes, then we're done, because that's the top line. There's nothing to do. If the answer to that is no, then we ask, is there anything above this line? If the answer to that is yes, then we drop everything above one line. And check again. If the answer to that is no, then we're done. If the line is not clear, well, done is not right. Next line. If the line is not clear, indent that. All right, so if the original line check says no, it's not clear, then we just go to the next line. Okay, this is a terrible algorithm, but it doesn't require me to track which lines were cleared and have to adjust coordinates or anything like that. This is just going to brute force this thing. I'll post the code on the Atari Age forum, so if you want to, you know, write your own better one, okay, go for it. And I'm going to make this a subroutine just because I want to get it on its own. So we'll call it adjust board. Okay, so we're going to call this after all rows have been checked. So at this point, I don't need to save any registers or memory or anything. Everything's wide open. So we're going to start from the bottom of the board, which is index 19. I'm going to save that in F0 because I have a feeling we're going to clobber Y at some point. Actually, you know what? We need to step back. We need to step down one level deeper. And that is, I want a subroutine that just takes a line and moves the line above it down. So we're going to go move line down. Now, I think what we're going to do with this is we're going to assume that the address of the line is in FEFF. So we're going to take that address and we're going to make a copy of it to FC. FD. Well, actually, hold on. You know what? It just occurred to me that this might actually be better to do it from the top. Because if you start from the top, you just work your way down, and every time you come across a clear row, you drop everything above it. And then you continue moving down. You don't need to worry about multiple rows of things in a row. That would just take care of itself. You know what? I think that would be easier. We're going to start from the top. So screw this. We're going to do it differently. All right. So let's do this then. I shouldn't have erased that. Adjust board. You know, I've written the Tetris on a PC so many times in so many programming languages, and this is super easy on a PC. It's like no problem. It's just kind of a pain here. All right. So here's what we're going to do then. We're going to start from the top. We're going to start from 0. And we'll save that to F0. Oh, well, thank you. This is actually Vim, but close enough. Although I don't know if that's going to scare you off, but Okay, so we're going to start from the top of the board. And, now I kind of need to take that is line clear routine that I did and make it its own thing, because I need it here too. So here's what we're going to do. In fact, we're going to make it even better. So we'll do is line clear. And we'll pass the y coordinate of the line in the accumulator. So we load 1 because we want to start from index 1. Then jump to that routine I had. What was it called? Cell to address. And then we do the line thing. I remember how this works. So we do load. We start from 9. And then, okay, so if this equals 0, it's not a row or not a line. Otherwise, we decrement, branch on plus, it's a line, check, loop. Now, if we get to this point, it is a line. So I like to use the carry bit for this. So if it is a line, we're going to set the carry bit. So we'll set the carry bit and then return. If it's not a line, we'll clear the carry bit and return. Now, sometimes the carry bit will already be set or cleared based on the branches you pick, but I don't really feel like thinking about that right now, so I'm not going to do that. All right, so up here where I did the line clear before, now I have a subroutine for it, so we'll just rip this out. How did we do that? Okay, here we go. Line check loop. Oh, wait, I can't use F0 for that. Load A, current piece, YY. Ah, here we go. So here we're going to do, jump to that subroutine. And if the carry bit is set, it is a line. So if it's clear, it's not a line. So this we can get rid of. This we can get rid of. Okay. So I think that factors that out. I didn't call it is a line, did I? What did I call it? Well, search for a line. It was something a line. Is line clear? That's what I was looking for. I have a bad habit of forgetting what I named things right after I name them. Okay. So I just want to make sure this works. So now we have a subroutine for checking line clears, which will make it easier to adjust the board afterwards. So let's see what we got here. If I can clear a line. I'm making this really difficult on myself, aren't I? That wasn't where I wanted that. Jeez. The RNG gods have cursed me. There we go. Okay. So we have the line detection routine factored out as a subroutine now. So what we'll do now is we'll make use of this. So, all right, so now we can very easily tell if a line is clear by just loading the line into the accumulator and jumping to is line clear. So, easy. Now, so what we're going to do then is we're going to start from the top of the board, work our way down. If we see a clear line, we're going to take everything above, drop it 1 tick, and then continue on our way. And this should work fine in the presence of consecutive lines being cleared. Well, actually, you know what? We don't want to start from the top. We want to start from 1 past the top. Because if we start from the top, and it's because when we look, the line is clear, we're going to drop like the roof down, if that makes sense. So you don't do anything on the top. If you clear the top row, there's nothing to drop. So instead of starting at 0, we're going to start at 1. So here we go. Actually, you know what we can do? Because this is actually really easy to do now. We're going to do a little optimization trick here. What we're going to do is we're going to loop until we hit a line that is not clear. because we don't need to do anything until we hit a line that hasn't been cleared. Because there's nothing to move. So we'll loop until we hit that, and then that's where we'll actually start doing something. So, however, okay, so we'll call this the skip space loop. So we're going to have to reload Y. It's kind of redundant, but actually, no, we're going to reload A. It's going to be A. And jump to is line clear. Now, if the line is clear, if the line isn't clear, then now we need to actually start checking things. So, carry is clear if the line is not clear. Boy, that's confusing, isn't it? Okay, branch on carry clear to start checking. Nice descriptive labels. Okay, start checking. All right. Otherwise, we're going to increment Y. Go to the next. Actually, not increment Y. We're going to increment F0. Go to the next one. Now we need to stop on. It's 20 high. We need to stop on 19. So we are going to need to load this. You know what I'll do then? Here's what we'll do. We'll start with it already in the accumulator because we need to load it at the end to check it. So we'll load that, compare it to 19. If it doesn't equal 19, we need to continue the loop. Okay, so this will get us, if it does equal 19, then we're done. So we'll RTS. All right, so once we're here, we've just hit the first row that actually has a block in it. So now we know we need to start checking for clear lines. But this row has a block in it, so we can go to the next one. We know this isn't one. So we'll increment our index. And now we start doing this for real. So check empty line loop. So now, I'm going to do the same thing here. We'll load it beforehand. Wait. Actually, I don't think I know what's in the accumulator at this point if I branched there. But we'll go ahead and check to see if the line is clear. Now, if the line is clear, then we need to drop everything above down one level. So if it's not clear, then we just keep looping. So I kind of did this by eye. If the carry is set, the line is clear. So we'll branch to drop lines. So here's drop lines. Otherwise, this row is not clear, so we need to keep looking. So we'll increment the index. I keep typing 9. Load it up. Compare it to 19. If it doesn't equal 19, continue checking. Okay, so if I've worked this out correctly in my head, once we reach this point, we now have the index is now at an empty row, and we need to drop everything above it. But what I think I'm going to do, just for the sake of optimization, because I don't want this to be too stupidly slow, when we get here to start checking, we have the index of the topmost row that actually has blocks in it. So we know once we drop that row, we can stop because there's nothing above it. So I think what I'm going to do is before I increment F0, I'm going to take it and I'm going to store it. I'm going to make a copy of it. I'm going to put in F1. So F1 is the upper limit to what we need to check. And every time we drop a row, we can increment F1 and move that limit down. So just a little bit of optimization, because otherwise we're going to be going through every single row up the board. And that will work. That's fine, but it's going to be very slow. So let's see if we can speed that up a bit. It might not be noticeable. I don't know. this might be premature optimization, but I figure we might as well do it. All right, so what we need to do here is this. When we get to drop lines, F0 contains the y coordinate of the empty space in the grid. So every row from where we currently are up to the index we stored in F1 needs to be dropped down one level. So here's what we're going to do. Now, since we called isLineClear, now this is a side effect of isLineClear, is that the address of the line that we checked is going to be in the FE and FF memory locations. So that's already there. So what we're going to do then is this. I think what we're going to do is we're going to move that address up one row. So we'll take FE, it's 40 bytes to the next row up. So we'll take that 40. And then, we have to assume there might have been a carry. So subtract 0 from the value in FF. So if there was a carry, that applies. Oh, no, I don't want an FF. I want it in FC and FD. All right, so what we have now... Wait, no, I do want an FEFF. Never mind. So what we've got now is... wait a minute, what did I do? There. So what we do now, we have the address of the row above the what we want to clear, which means that we can now very easily offset between the two rows. So what we're going to do then is we need to move all the blocks down one level. So we'll call this the drop line loop. Well, this is going to drop a single line. We're going to have to expand this to go all the way up, but we'll get to that. So what we're going to do is we're going to how are we going to do this? Okay. So the gist of what we're doing here is we're going to load I'm going to load. I don't think I can use X for this, can I? Okay, this isn't quite what I wanted. You know what? I don't want that address there. I do want an FCFD. My plan was to index by 9 and then store like 49, but I don't have enough registers. All right, so we will store the updated address in FCFD. So in effect, what we have now is the address we're reading from is an FCFD. The address we're storing at is an FEFF. So we'll load from FC, store it to FE, and loop. Now I'm thinking starting from the bottom might have been better, but you know what? Who cares? Let's press on. All right, so that will take one row and drop it one space. Now at this point, we actually need to continue all the way up, but wait a minute. No, we don't. Here's what we're going to do then. I got an idea. So this is going to be tricky. If this works, it's going to be great. All right, so this takes the old, this row and moves it down. What we're going to do after that is we're going to load 0, write it to the old row. We're going to clear it. And then once we finish clearing that, we're going to step back one row. Okay. So my plan here is that we're going to kind of walk it back. So now that we've dropped that row, the row above is blank. So we're going to step the index back. and process that row again. It's kind of silly, but I think it's going to save a lot of code. I just got to figure out where to jump now. So now we need to jump to... Actually, we need to load F0 and compare it to F1. Because at that point, if it equals F1, we're done. God, I hope I'm getting this right. This is either going to work or it's going to be terrible. Okay. Otherwise, we're going to jump back up to... check empty line loop. I think this is going to work. Typos. I've been doing a lot of Ada lately, so I keep typing entry. We should be... All right. My microphone does that sometimes. I have no idea why. Sometimes the camera kicks out too. I don't know if it's the hardware or the software or some combination of both. Who knows? All right, let's see how disastrous this is. There's a chance that this is just going to work. Or it's going to be a complete disaster. We'll find out. Oh, jeez. You know what? I never called it. I do this all the time when I program. I spend all this time writing these nice, big, complicated functions, and then I forget to call them. And then I go test it. It's like, why isn't it working? You never called the function, you idiot. All right, so... okay, so I think what we want to do here is we want to set a flag or something that says we found a line. So what I'm going to do here... Okay, where do we start checking the lines? Right here, line check. We start checking lines right here. This is where we start. So I'm going to set up a flag. So I'm going to put 0 at F1. This is going to be our did we even find a row in the first place flag. So here is where we get to if we did find an empty row. So we're just going to increment F1. And then once we're done, which will be here, right before we generate our new piece, we'll check F1. And if that doesn't if it equals 0, we didn't find a line. So no line found. If it doesn't equal 0, we found a line. So we'll jump to adjust board. All right. Let's see what happens. I'm afraid. I'm kind of scared of this. All right. Of course, I need to make a line that actually has something on top of it, so there's something to drop. Oh, geez. All right. Okay. Nah. Okay, let's see what happens. Okay, it looks like it... Okay, I don't know what it did. It didn't work. That's for sure. Okay, but the code that calls it is fine. That's cool. All right. So let's go over this again here. So we start from F0. So we obviously got to this point here. Drop line, load. Okay, so is line clear leaves the address of the line in FEFF. So that's already there as a side effect of that function. So if the line is clear, we take that address, subtract 40 from it. That moves us up one row. And I put that address in FCFD. So that's going to be the row above. And then for every cell there, we load the value from the row above and store it in the row below. So we move it down, it drops. And then I erase the row above because we just dropped it. So you know what I'm going to do? I'm going to freeze it right here. So let's break this into pieces. So we'll freeze the code right there just to see what it looks like after dropping a line. Jump star is a very, very useful debugging tool. Come on, give me something good to work with here. All right, here we go. Was that right? I need to see that again. I didn't catch if that was correct or not. Oh, here's an easy one. All right. No, so okay, so this is just going crazy when it tries to drop that line. Okay. So let's move the jump star here. Let's put the jump star right before this loop. I want to make sure that this is where we're getting to. And I want to see what the state of the board is when we hit that specific point. Whoa. Oh, yeah, that's right. The line is clear. Okay, that's fine. All right. Okay. So everything's cool before I go into this loop. And then this is where all hell breaks loose. So here is what I think I might do. I don't see why this would not be working. This seems like it should be correct. You know what? Let's get rid of this erasure here. And let's just see if the next line is kind of duplicated down. So we'll get rid of the erasing the line part, and just look at the copying the line above down part. All right, so if this works, the bottom two lines should look the same. Oh, I didn't clear the line. Okay. Okay, that's fine. That's exactly right. It took the line above and it copied it down. So something's wrong with the code that's clearing that line now, which I don't see why. It's just writing 0 to that location, which clears the cell. I don't know. Why would that be screwed up? That doesn't make any sense to me. I haven't touched any of those variables or any of those memory locations. And I reload A every time through the loop. Interesting. All right, let's put that back in there and look at it one more time. Maybe I can look at what it's doing and figure out where this is going wrong. Oh, this is cute. All right, so this one... Okay, this is interesting because there's only one block. No, I haven't finished the line yet. Okay. So let's see. Okay, I see what it should look like. It should move that row down. Oh, it is right. It is working correctly. I think I just didn't recognize it. So it actually worked. It took that row and moved it down. Okay, that's fine. That's perfect. So up to this point, this is working correctly. The problem then is here. So what I intend to do here is that since the row above is now empty, I want to back up the index and just process that row, and that way it'll keep moving all the stuff down. So F0 is the index that's being processed. So if I decrement F0, it's like stepping back a row. So let's look at this then. So I step back a row, but I compare it to F1 because F1 is where we're supposed to stop. So if I'm at that point, then there's nothing to do. We're done. Except I'm not, am I? You know, I'm going to get rid of that. All right, let's try it this way and see what happens. I think that part might be wrong. But so far, it is actually doing what it's supposed to do. I don't like the keybinds on this emulator. I need to fix it. I've moved to a different emulator. I used to use Atari++. Now I'm using Atari 800. Atari++ couldn't handle the stuff that... what's his name? Synthpopalooza, Bobby Clark. The stuff that Bobby Clark was doing with my music, for the music for my games, I couldn't handle it. All right, let's see what happens here. Okay. And it's stuck in a loop too. It's just frozen. Okay, so Okay. All right, so let's look here. All right, so we check empty line. If it's clear, we drop lines. All right. Okay, if I don't comp, it's just going to keep going until it hits the top. So I definitely need to have this in there. All right, how about we do this the tough way? We'll compare it not to F1, but to 0. Okay, so we'll forget about the optimization, because optimization doesn't matter if you don't get it to work. F0 is the y coordinate of the blank row, and F1 is the first row that actually has stuff in it. The idea was that we can stop looking once we hit F1. But that might be an optimization I shouldn't be trying to make right now. Man, okay. I'm going to have to step through the code. I think we need to hit this with the debugger because I'm not sure what's happening here. Okay, so let's... it's debugger time. So we're going to pull up the listing. Okay, we want... search for drop line loop. All right, we want to break on address 434F. Let's see what happens here. I don't remember. I haven't learned the commands for this debugger yet. I'm used to the ones from the emulator I used to use. So BPC 434F. Oh. Okay. BPC. Oh, yep, go eat. Thanks for stopping by. 434F, okay. That's wrong. Okay, let's start over. I did something wrong. Let's see. BPC. It's 434F, right? Breakpoint set of 434F. All right. Okay. So now we'll get to that breakpoint, and we'll see what is actually happening here. Ooh, can I slide it under there? There we go. Oh, I could have cleared a row right there. I wasn't paying attention. I'm like actually playing Tetris right now. Okay, here we go. Okay, so we hit the breakpoint. And unfortunately, that hides the visual, but let's see what we got here. So if we look at F0, so F0 is the row that was clear, which is hexadecimal 13. So it's going to be row 19, which... that doesn't seem right to me. That seems very wrong. F1 is definitely wrong. Huh. Interesting, but let's step through the code and see what happens here. Actually, no. I'm going to go back to the code for a moment, because that value did not look right to me. In fact, you know what? I want to reset. Okay, I clearly have no idea what the R command does. I keep thinking R is reset. I don't know what that is. Okay, I want to clear the very bottom row, so that way I know it should be row 19. So let's see if we can get that to work. That's the row I want to clear, the very bottom row and the very bottom row alone. I'm going to find my mouse cursor here. So we'll break again on address 434F. I've got to write down the commands for this debugger because I just can't remember them. Oh, wrong button. Okay, so I want to clear the very bottom row. All right, here we go. Okay, so we just broke at address 434F, which is DEC $F0. All right, so at this point, F0 should, I believe, be... okay, it should be 19 here, yeah. Did I screw that up before? I don't know, okay. So F0 is the row that we just cleared, which is 13 hex, which is 19. And then... oh, I put... oh, I disassembled it. Whoops. Okay, so... D is a command from the last emulator I used. Okay, so 13 is the row that we just cleared. Now, the next address after that is supposed to be the first row that actually has blocks in it. And that is definitely wrong. That is definitely not 1. Okay, I can't remember the step command here. G, execute 1 instruction. Okay. So here we go then. So, all right, we should have just decremented the row. So that's going to walk us back. Okay, so we're going to loop again with row 12, which should now be empty. Okay, then we compare it. Compare to 0. Oh, yeah. Okay. That's my temporary thing. All right. All right, branching. Okay, so now we're branching back up. Oh, yeah, here we go. Jump. Okay. So now we're going to, we should be checking to see if this row is clear, which it should be because we cleared it. So this is the row is clear function here, I believe. It is, yeah. Okay, this is now obtaining the address. Okay, we got the address. Now it's checking to see if it's clear. Just going to go through this loop. Clear the... Oh, it says it's not clear. Why does it say it's not clear? Oh, it does say it's clear. Okay. But that doesn't seem right. No, it said it was not clear. Okay. Wait a minute. Why did it not branch? Okay, I'm confused. What's happening here? Okay, so let's see. I knew this was going to be the most complicated part. All right. Oh, I'm not stopping correctly. There should be a return right here. That might be my problem, or at least a large portion of it. I never actually terminated the function. I had a feeling I forgot that somewhere. Okay, so let's see what happens now. All right, here we go. We're gonna clear this row. Okay. It didn't drop, but it didn't, like, crash or anything. So we're still kind of... Okay. It's clearing the rows. It's just not dropping anything. All right. That's better. Okay, so here we go, then. If the line is clear, we drop lines. Why is it not dropping lines, then? All right, adjust board. Here we go. So we start from row 1 because we never adjust row 0 because that's the very top. Store it in F0. Okay, so we're looking at this. The current index we're looking at is index 1. Then why am I doing it that way? I think I thought I needed that in Y at some point. All right. Is the line clear? If it's not clear, this is where we start looking. So we start looking here. We copy the line we're currently at because that's the topmost line. Then we start looking at the line underneath that. If that line is clear, we drop lines. We load the line, subtract 40, so here, load the next one, sort up there. That's fine. We go through the drop line loop. All right, so it looks like it's not dropping the lines anymore, so let's go ahead and throw the jump star in here. I don't know how that broke. I really don't. Let's see what happens. Because it was dropping the line previously. I somehow managed to break that. It's never hitting that. Why? Why is it not hitting that? Is line clear? Branch on carry set, drop lines. Increment F0. Load it. Compare it to 19. If it's not equal to 19, go back to the loop and check the next line. Boy, that's weird. I don't know what's going on here. Now it's not dropping. So it must have been... Oh, you know what? It must have been dropping the lines. All right. Something's weird here. All right. Is line clear? Oh, I'm thinking about this backwards. Is line clear means the line is full. I should change the name of that because I'm just... I'm reasoning about it completely backwards. This is just a dumb naming on my part. I was treating that as if the line was empty. My logic is completely backwards here. I should call is line full or complete or something like that. This is just a case of bad naming. Okay, so having done that, I need to revisit my logic here. So, all right. If the line is full, it sets the carry bit. So, branch on carry set, start checking. If the line is full, it sets the carry bit. But we don't want that. The other way around. Okay, now let's see what happens. Wait, hold on, I got to get that jump 0 out of there. That jump star. This, definitely emphasizes the importance of naming things properly because you will confuse yourself sometimes. Come on, random piece generator. Give me something to work with here. Oh, come on. Give me something. Oh, what is this? There we go. Okay, so this... Okay. Well, that's something. It's not completely busted. Okay. Let's look at this again. Okay, so if the line is full, we start checking. Great. If the line is full, if the line is not full, we drop lines. So we're going to throw the jump star back in here. And we'll see if we're ever getting to this point. Okay, it should be easy to make a line now. Here we go. No, we're never getting there. That's interesting. Okay. Why not? This would be an enormous pain to step through with a debugger. So I'm hoping to find a shortcut and like a way to test this. Okay, let's see. Okay, let's walk back even further. We're going to put the jump star here. Let's see if that initial check even passes. It could be that check is failing for some reason. I feel like I'm so close to having this work. I'm like right there. No, the initial check is failing. Okay. Well, let's look at that then. So, all right, so we start with 1, store it in F0. Is the line full? If the carry is set, the line is full, and that's where we start checking. Oh. Wait a minute, no, okay. Branch to start checking. So this is never returning true. All right, so inline full takes cell to address, wants the x coordinate in 1, the x coordinate in x and the y coordinate in a. All right. If it's not a line, it clears the carry bit. Okay, this should be branch on carry clear. Oh, this is completely wrong. This is not what I should be checking. I should be checking if there's anything on that line at all. That's what I need to look at. This is the wrong function to check. So let's, all right, we'll do this differently then. So we're going to have to JSR cell to address. Oh, I see what's wrong. I'm looking at just the wrong. I'm using the wrong function for this. I need I need the opposite of isline full. I need isline empty. So this is going to be the same thing. We'll just duplicate this. I'm just misusing my own functions. That's what's wrong here. But instead, we're going to say okay, if we load the cell and it's not 0, then it is not empty. And if it's not empty, we're going to set the carry bit. So I like to use set as like the positive case. So this will be clear the carry bit. All right. So we want to check not that the line is full, that the line is empty. And if it is not empty, that's where we start checking. And down here, we don't want isline full. We want isline empty. And if the line is empty, we drop the lines. Boy, that was dumb. All right, so now... Oh, man, that was stupid. I'm really dumb sometimes. Okay. And... Okay, perfect. It froze. That's the first jump star. We hit that one. So now let's see if we hit the second one. This emulator loads much faster than Atari++. I don't know why it was. On my laptop, Atari++ loads really fast. For some reason on my desktop, it doesn't. I don't understand why. Okay, good. We hit the second jump star. Oh, suddenly it's all coming together. All right, so let's see what happens now. Ugh. Ugh. Okay. Whoa! Okay, not what I expected, but it's something. Okay, so we still got problems, but at least we've got something working here. So, all right, so drop line loop. All right, so let's do what we did before. And now we're going to throw the jump star here. So we'll stop after one line drops just to make sure that's still doing its job properly. And we'll see what we need to do from there. So we just need to get this step by step. We got to make sure all the individual steps work. Then we'll be fine. Okay. It looks like it did not work. So we did the drop line loop, but nothing happened. All right. So let's see why. All right, so when we drop lines, it means we're currently looking at an empty line. So we take the address of that empty line, subtract 40 from it. That gets us up to the row above, and we store that address in FCFD. Great. And then the drop line loop, we load the data from that address and move it down one. So that is going to copy that data down. You know what? Let's get rid of this clear part of it for the moment. And let's see if just the copying part works. I wonder if it's just somehow like clearing the wrong spot or something. Well, this is going to be an informative video when I post it on YouTube later. Let this be a lesson to you. This isn't how you don't program stuff. Oh, whoa. Okay, that was not good at all. I'm not sure what happened there at all. Okay, I think we need to set a breakpoint in the jump line, in that drop line loop. So let's go ahead and pull up the listing. Okay, so here's drop line loop. It's at 4356. Okay, so I want to clear the bottom line just because it's easier to rationalize. It's kind of the extremes. You want to test the extremes. That I generally find if the extremes work, you're good. Okay, so we just broke there. So at this point, when I look at the value in F0, the value in F0 is 11. That is not right. That is very, very much not right. Why is that 11? And oh, okay, F0 and F1 are still wrong. Okay, so that seems to be the source of the problem here. So all right, so we start from row 1. Is line empty? Let's look at this. Okay, so load number 1, cell to address. If we find something that's not 0, it is not an empty row, and we set the carry bit and return. Otherwise, decrement it, branch on plus, line check loop, clear the carry bit, return. That I think that's fine. What's the problem here, though? So, all right, we jump. Okay, is line empty? If the line is not empty, this is where we start checking things. If the line is empty, we increment the line we're looking at. Then we load it and compare it to 19. Because if it's 19, then we're at the bottom and we're done. So if it doesn't equal 19, we keep checking, keep looking for an empty line. Now, once we find an empty line, we store that in F0. So here's what we're going to do. We start in F0 and F1. Wait a minute. It's already in F0. We should just start in F1. And then we increment F0. So once we find an empty line, we start looking at the next line down. No, once we find a non-empty line, we start looking at the next line down. Oh. No, never mind. That's fine. Okay, so I think I want to break here. I want to know what line it thinks it's on once it starts doing its thing. I don't need a breakpoint for this either. I can just throw a jump star here. But I need to know what's in the accumulator at this point. Actually, no, not the accumulator. I need to know it's in F1 at this point. So we'll put the jump star right here. Okay. All right, so I want to clear the bottom row. Okay, so it should find the first non-clear row as being the row, the second to bottom rows, which is 18. So let's look at the memory here. So F0 we have 1. That's not right. Oh, I disassembled it again. 1. Why do we have 1 there? That's not right at all. Oh, it hasn't updated F0 yet. Okay, what's in F1? 0? How is 0 in F1? Oh, I do need to load that because it gets clobbered by isLine empty. But it was still 1. Why would... Okay, something's wrong here. All right. Isline empty. Okay, we set up this is just like isline full. We set up a cell address. If we find a value that is not 0, the line is not empty. And we set the carry bit. Wait a minute, that's backwards. If it's empty, we set the carry bit. I got this all backwards again. Is line empty? No. Start checking. Oh, geez. My function was backwards. It was backwards this whole time. Okay. Do I still have jump stars in here? I do. After the drop line loop. Okay. Now let's see what happens. God, it's the little things that kill you in assembly. Oops. I think that worked. It dropped the line. Okay. So, again, we're correct up to this point. So now let's go ahead and get rid of the jump star. We'll see what happens. Now, this is still the inefficient method. Is going to go all the way up the screen. But it needs to work before we make it work well. Okay, so now... that wasn't right at all. That was not right at all. That was right. That looked good to me. I don't know why the bottom row didn't work, though. Okay, it looks like it's working, just not on the bottom row. So we got some sort of an edge case problem here. Nice if I get some decent pieces. Yeah, I think it's working. Ooh. Oh, okay. Is it the bottom row that's screwed up, or is it multiple rows that are screwed up? All right, I feel like it's clearing multiple rows, and that's what's screwed up. But let me try again, because if there's going to be a screwed up location, it's going to be the bottom row, and of course I get stuck with this piece to start with. All right, I can compensate for it. All right, so I want to clear the bottom row and the bottom row alone. Here we go. Okay. All right, so something's wrong there. So I think there's two problems. One is the bottom row. Something's wrong with clearing the bottom row. And something's wrong with clearing multiple rows. But okay, you know what? I think I see what's wrong with clearing the bottom row. I'm not going far enough. I need to check. I need to go all the way up to 20. Because, yeah, okay. That's the bottom row problem right there. I just found that. That's obvious once you see it. Let's make sure. Okay, so let's clear the bottom row. Perfect. Bonk. Okay, so bottom row clears fine. So now it looks like the problem is in clearing multiple rows. It looks like there's a glitch with that. So let's see if we can set this up. Okay, so now we can at least watch it and see what it does. Okay, so it doesn't. I'm not sure what it did. But let's look at that again. Let's look at the bottom. Let's look at that logic. So it looks like the only problem right now is clearing multiple rows. And I thought this was going to be the tricky part. So let's see what we got. This might be the last bug. I got to admit, I was real close to just giving up on this whole thing. All right, so after we finish dropping a line, we walk the index up one. So this is we then look at the line above and then drop that line. So wait a minute. Okay, so we do that. We drop the line, compare it to F1, because F1 was the first line that had anything in it. And even because that, we're done. Otherwise, we jump to check empty line loop. All right, so it should find that, right? So if we jump check empty line loop, and we now have one row up, we check see if it's empty. It should be empty. It should always be empty. So I think what we're going to do then is instead of jumping to check empty line loop, I'm going to do a JSR to we're going to load X. We know that the next row up is empty because we cleared it. So I'm going to load X number 1. I'm going to jump to cell to address. And then we're going to jump to drop lines. So we just keep dropping lines until we reach that top part. But every time we do this, we need to increment F1 because we're moving the top down. Okay, that was a lot of stuff I just threw out there, but I think this might work. Or at least it'll work better. Let's see what happens. So I got to set up a multi-line clearance here. That's a single line, but it might make a multi-line easier by smoothing that out. Okay, we're set up for a multi-line clearance now. Just got to get the right piece. That's not the right piece. That is. Whoa! Okay, so all hell broke loose there. All right. That was interesting, though. That was definitely very interesting. So we're continually decrementing the index and incrementing the top. So at some point they should meet, unless they cross over each other. Well, no, because we decrement, then we compare, then we increment. So that should be fine. You know, let's get rid of the increment. That's kind of just an optimization. But you know what? We can not do that right now. All right, so I need another multi-line clearance here. No! Stop giving me these things. Those are always the worst pieces. Okay, screw it. You know, trying to set this up on purpose is really hard. I just gotta kind of brute force it. Oh, here we go. No, not quite. Come on. You know what? I'm just going to play Tetris, and when it happens, it happens. That was a goof up there. Okay, perfect. We got two pieces that'll do it. That's one of them right there. It's clearing the lines. It's just not... Yeah, it's just not... Okay, I don't know what that just did. All right, I'm not sure how to fix this bug. It's unfortunate. Okay, so after we can drop one line. That works just fine. That is peachy. And you know what I could do, which is terrible, but it would work. Is every time I drop a line, I just restart the function. Okay, this is awful. This is so stupid, but I'm going to see if it works. Because, you know what? I'm happy to just brute force this at this point. I'm just sick of fighting with this. If you want to improve it and make it better, I will post the code and you can, you know, it'll be a fun exercise. But I'm just going to do this, we're going to brute force this just to get something working. Eventually I'll get a multi-line clear. I just need to wait for the stars to align. Ooh, that's ugly. Ugh, this is not a good... This is not... No, I didn't want that there. Ugh, boy. This game hates me. I just want to set up a multi-line clear. Come on. Man, this game has it out for me right now. Screw you, Pokey, and your random number generator. You hate me. I'm waiting for the right piece. There it is. Okay. Here's a two-line clear. Oh, it worked. It worked. Okay. That flicker, you can see it flicker though. I think it's too slow. I think it's actually crossing 2 frames. But you know what? I don't care. All right, so that is a terrible way to do it. But it gets the job done. That could be done so much better, but I don't really care at this point. I just want done with this thing. So I think that's where we're going to stop. I think it's going to be the end of this series. Yeah, it was fun. I got to mess around, do some coding and stuff like that, and go over some of the Atari stuff. So if you're interested in the 5200 and you want to code some stuff for it, you know, hey, go for it. All this code is available on the AtariAge.com forums in the Atari 5200 section. You can find a topic there for this video series. You can go download the code if you want to play around with it and improve this Tetris game. You know, do whatever you want with it. I don't really care. Make this line clear algorithm a little more efficient if you feel up to it. Add the next box, add some scoring, add level progression, all that sort of stuff. You know, do whatever you want to do. I mostly just wanted to do this project to demonstrate the use of Mode 4 and the tile-based graphics. And I thought Tetris was a great way to do it. And I'm planning a block and pit type puzzle game for the 5200 at some point. And I kind of wanted to do this for myself just to see, just give me some ideas on how I would approach certain problems. It's not going to be Tetris. It's going to be something else. But, the fundamentals are the same. And I wanted to get a little bit of experience with that type of game. So I thought I'd use this as an excuse to just experiment with that kind of thing. But I think that's where we're going to wrap it up for now. So if you follow along this video series, thank you very much. It's been a lot of fun doing it and kind of time consuming, but I think it was worth it. And I may do some more stuff like this in the future, not necessarily on the Atari, but with some other programming stuff. But we'll just have to see how I feel. But I'll be signing off for now. And again, thanks for watching if you've stuck with me this far. And we'll be back with some more videos at some point.